Hello everyone, I am Mary Grace Flores and I will be reporting about word problems involving algebra. So basically algebra is a very broad branch of mathematics. So we can encounter a lot of word problems that we can apply. However, I will just provide you today with three problems. The very common one, those are number problems, age problems, and motion problems. So this is just a recap of what we learned basically in college and in high school. So, in solving word problems, we do have steps that we need to follow. I mean, not necessarily all the steps, but this will serve as our guide in teaching our students. And at the same time, of course, this is our guide so that we can come up with a solution and a conclusion. So, first, we need to determine or write the given. Of course, in every problem, these are the given that we do have given that we can use to have a solution. And then we do have also what is asked on the problem. We need to determine that. That is very important. And also, when we can determine the given and of course what is asked, we can now represent the given. We will now have representation. Any variable that we can use for a certain problem. And then some problem requires illustration, some requires us to create a table so that we will be able to picture out and it will be much easier for us to create an equation. And then once we have an equation, then we can have the solution or solve. We can be able to solve the problem and then once we have the answers, we can now provide a conclusion. So say for example, we have a number problem here. The sum of two numbers is 15. The difference of the same two numbers is 7. What are the two numbers? So the given, we have the sum of two numbers is 15. The difference of two numbers is 7. Now, what is asked? Of course, this one. What are the two numbers? So we will need to find the two numbers that this problem is talking about. So we will now represent. So for me, um, it's up to you, but I will be using two variables today with this problem. So I will now let x be the first number and then let y be the second number. Okay? So the next one, since we now represent the first and second number, we will now create an equation. So we have here the sum of two numbers is 15. So when we say sum, very basic, it is the result when adding two numbers. So the first equation will be x plus y is equal to 15. The difference of the numbers, the difference of the same two numbers is 7. Of course, the difference, that means the result when subtracting two numbers. So I have here x minus y is equal to 7. So since we have the equation, we can now come up with a solution. So solving equations with two variables, we have a, s- a lot of what shall we call this? We do have a lot of ways to solve them. We can use elimination, substitution, etc. But based on the given, I decided to use elimination because it is much easier. So we have here two equations. X plus y is equal to 15 plus x minus y is equal to 7. I use the addition sign because we can easily crash out one variable here. So we have, basically I just added two equations. Okay, so we have here x plus x is equal to 2x. So we can crash out this one basically because positive y plus negative y is equal to 0. And then we have here 15 plus 7 is equal to 22. So we have a new equation, 2x is equal to 22. Now divide both sides by 2. Divide both sides by 2. So we have here x is equal to 11. So since we now have an idea of the first number, we can have substitution. Any of the equations, by the way, but I will just use the first one. So we have x plus y is equal to 15. Substitute x with 11. So 11 plus y is equal to 15. We have to transpose 11 to the other side. So that's left with y is equal to 15 minus 11. So y is equal to 4. So let's not actually try with this with this one, with the second equation. So x minus y is equal to 11. So if we can imagine here, we have here, oh, let's substitute. So 11 minus y is equal to 7. Okay, so that's left with negative y is equal to 7 minus 11. So negative y is equal to, oh, I'm sorry, is equal to negative 4. Okay, so divide both sides by negative 1. Basically, I'm sorry, y is equal to 4. So we have the same answer. So therefore, the conclusion, we have the two numbers are 11 and 4. Okay, so when we add them, 11 plus 4, that is equal to um, 15. And when we subtract them, 11 minus 4, it's equal to 7. Okay, all right, next. So another one is also age problem. Okay, this is very common. So let's have the given number 2. I'm sorry. Phil is Tom's father. So Phil is 35 years old. And then 3 years ago, Phil was 4 times as old as his son was then. So how old is Tom now? So we have the given. Of course, we have Phil's age, 35 years old. And then the other one is we know that 3 years ago, Phil was 4 times as old as his son was then. So what is asked? We have Tom's age now. Okay? So we need to find what is the age of Tom now. Okay, so we have a representation. I use t as the variable, so let t be Tom's age now. So for age problems, for us to be able to create an equation, it will be much easier if we come up with a table. Okay? So we have here Phil and then Tom. So we know that their age now, Phil is 35, and then Tom now we will represent as T. We get this from our representation. All right. And then 3 years ago, of course, 3 years ago, that will be Tom 35 minus 3. Phil is 32. So we represent 3 years ago, T minus 3. So we just subtract it by 3. Okay, next. So by this we can formulate an equation. So we know that Phil was 4 times as old as his son was then. So we have Phil. So this one is we have 32. Here we have 32 is equal to 4 times t minus 3. We get t minus 3 from here, 3 years ago. Okay, so 4 times, this represents as Tom, I'm sorry, this represents as Phil's age is equal to Tom's age. Okay, next. So we've got the solution here. So since we have 4 times the quantity of t minus 3 is equal to 32, so we just have to distribute this. Okay, this distribute. All right, so we've got 4 times t is equal to 40 minus, since 4 times negative 3 is negative 12 is equal to 32. We transpose 12 to the other side, or sorry, negative 12 to the other side. That makes it 40 is equal to 32 plus 12. Okay, so divide. That makes it 40 is equal to 44. So divide both sides by 4. Cancel this out. T, that makes it t is equal to 44 divided by 4 is 11. Okay, so we have a conclusion. Therefore, Tom is 11 years old now. Okay, so another problem, very common word problem that involves algebra is also, I'm sorry, motion problems. So I will be providing you with motion problem. So Mrs. Benavides leaves Burbank at 9 a.m. and drives west on Ventura Freeway at an average speed of 50 miles per hour. So Miss T. Will leaves Burbank at 9:30 and drives west on the Ventura Freeway at an average speed of 60 miles per hour. So we do have different rate here, different speed, and Miss Benavides leaves the place 30 minutes earlier than Miss Tewell. So the question is, as at what time will Miss Tewell overtake Mrs. Benavides, and how many miles will they each have gone? Okay, so that leaves us here. So what is the given? We have given, of course, Mrs. Benavides' rate is 50 miles per hour. I'm sorry, that should be per hour only. And then Miss Tewell rate is 60 miles per hour. Okay, so we should have here another one. So Mrs. Benavides lives at 9 a.m. and then Miss Tewell lives at 9:30 a.m. So what is asked? At what time will Miss Tewell overtake Mrs. Benavides? So we will be looking for we will be finding out the time and how many miles will they each have gone. So remember, we will need to find the distance. But before that, um, we will just have a quick recap on the formula. So that will be, okay, sorry, 1 second so that I can write something down. Okay, so the formula will be rate, speed, or rate is equal to distance over time. So that makes it, if we need to find the distance, that will be rate or speed times time. Just a quick recap. Okay. So now we will have representation. So I used variable t. So let t stand for the time Miss Tewell drives before overtaking Mrs. Benavides. So if we let t, since Mrs. Benavides leaves earlier than 30 minutes earlier, or that's half an hour earlier before Miss Tewell. So we have another representation. I let t plus 1/2 stand for the time Mrs. Benavides drives before being overtaken. Okay, so we will have now the table. So we have here Miss Tewell and Mrs. Benavides. So of course, we have here rate times time is equal to distance. So we have here Miss Tewell rate is 60 miles per hour. Mrs. Benavides, we have 50 miles per hour. Now we will have the time. So we have here, as earlier, T will be the time for Miss Tewell. T plus 12 will be the time for Mrs. Benavides. So we have here T and then T plus 12. So formula for distance, rate times time. So 60 times T is equal to 60T. 50 times T plus 12 is equal to 50 times the quantity of T plus, I'm sorry, not 12, T plus 1/2. Okay, so based on the table, we can create an equation. We all know that they do cover the same distance. So we have an equation that will be 60t is equal to, or 50 times the quantity of t plus 1/2 is equal to 60t. So since we now have a distance, I'm sorry, since we now have an equation, then we can come up with a solution. All right, so we have here distribute 50. So 50t, 50 times t, 50t, 50 times 1/2, that makes it 25, is equal to 60t. So I choose to transfer the 50t here. So 25 is equal to 60t minus 50t. So 25, or that comes up with 25 is equal to 10t. So we divide both sides by 10, so we've got t left. So t is equal to, crush out the 10, and then 25 divided by 10 is 2.5. So we know for a fact that 2.5, it took 2.5 or 2 hours and 30 minutes for Miss Tewell, or for Mrs. for Miss Tewell to overtake. Ah, it took 2 hours and 30 minutes for Miss Tewell to overtake Mrs. Benavides. Sorry about that. Okay, so since we now was able to find the time, so since Mrs. Uh, was 9:30, sorry. So Miss Tewell leaves at 9:30, so we just have to add that for 2 hours and 30 minutes. So that makes it 12 noon. Okay? So now let's get the distance. All right? So since we now get the time, so we'll just have to substitute it. So 60 times 2.5 is equal to, since they should have the equal distance because they cover the same distance as I said earlier. So we've got 50 times the quantity of 2.5 plus zero point 0.5. One half is zero point 0.5. This one. All right. So 60 times 2.5 is equal to 150, and this one is also equals to 150. So therefore, we have the solution. So Mrs. Benavides is overtaken at 12 noon by Miss Dewell, and each has traveled 150 miles. All right. So that ends my report, and thank you.